Let's dissect a real event-driven design built on Azure functions. Picture an order processing pipeline. An HTTP request lands an order, a function validates it and drops a message on a queue. A second function picks that message up, writes to Cosmos DB, and a third function reacts to the database change to send a confirmation. By the end, you'll understand exactly what triggers and bindings are doing here, where this design fails under load, and the trade-offs that shape every serverless function you'll write. Every function has exactly one trigger. The trigger is what causes the function to run, and it also carries the event payload. In our pipeline, the first function uses an HTTP trigger, the second a queue storage trigger, the third a Cosmos DB trigger that listens to the change feed. The key insight: the runtime owns the polling and listening for you. A managed component called the scale controller watches the trigger source and decides when to add or remove instances. You never write the listener loop yourself. Bindings are how a function connects to other services without you writing client code. An input binding pulls data in, an output binding pushes data out. In the second function, the queue message arrives via the trigger, and an output binding to Cosmos DB writes the document. No SDK initialization, no connection string handling in code, no manual serialization. You declare the binding and the runtime hands you a typed object or accepts a return value. The trade-off is real. Bindings are convenient but hide retry and batching behavior, and they cover fewer scenarios than the full SDK. For complex logic, reach for the client directly. Now trace a single order. The HTTP trigger fires, the function validates, and instead of writing the database synchronously, it puts a message on the queue and returns a fast 202 accepted. This decoupling is deliberate. The caller isn't blocked by downstream work, and the queue absorbs spikes. The queue-triggered function then writes to Cosmos DB through its output binding. That write appears on the change feed, which fires the third function to send the confirmation email. Each hop is independent and independently scalable, which is the whole point of the event-driven style. The hosting plan changes everything about behavior and cost. On the consumption plan, you pay per execution and scale to 0, but you pay with cold starts, often 1 to several seconds on the first request. The premium plan keeps pre-warmed instances ready and gives you virtual network integration at a higher fixed cost. The newer Flex consumption plan blends fast scaling with always-ready instances. Rule of thumb: consumption for spiky or low-traffic workloads, premium or Flex when latency and VNet access matter. Prices and plan features shift, so check the current Azure docs before you commit. Now the failure modes an architect must plan for. Cold starts hit the HTTP path first, so latency-sensitive front doors suffer most. Queue messages that keep failing become poison messages. After 5 delivery attempts, they land in a poison queue, and if nobody monitors it, orders silently vanish. The Cosmos change feed delivers at least once, so your email function can fire twice for the same order unless it's idempotent. An unbounded scale-out can hammer a downstream database, exhausting connections. None of these are bugs. They're the cost of an event-driven system you have to design around. Here's how to harden this design. Keep functions small and single-purpose, and never block on long synchronous work inside an HTTP trigger. Offload to a queue as we did. Make every consumer idempotent, using the order ID as a dedup key, so duplicate events are harmless. Cap concurrency and reuse clients as static singletons to protect downstream databases. Set the maximum scale-out and use the premium plan or pre-warmed instances when cold starts hurt. Store secrets in Key Vault reference through app settings, not in code. And lean on application insights from day one, because distributed event flows are nearly impossible to debug without tracing. So we dissected one event-driven pipeline. Triggers fire functions and carry the payload, bindings handle input and output declaratively, and the queue between stages decouples scaling and absorbs spikes. We saw the real failure modes: cold starts, poison messages, duplicate delivery, and connection exhaustion, and the practices that tame them. Your one concrete takeaway: before you ship any function, make its consumers idempotent and wire up application insights. Those two decisions save you the most pain at scale. Plan features and pricing change often, so confirm the details in the current Azure docs. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.